let us let us try to look here. So this is the binary search, but this have a requirement. You're able to do a normal search or linear search on an unordered or unsorted list. So if you have a list like that, 2, then you have 20, and then 3, and then 5. So this is unordered. But to be able to use a binary search, you need an ordered list. You know what is the meaning ordered, right? 2, 3,
Yes.
5, 20. So you need to order the list first.
Does sorting is faster than searching?
Again, sorry, again?
I'm sorry. Does ordering something can be more faster than comparing, like searching?
Yes, in the binary search, it have a better. It depends on the algorithm. I cannot give you a general answer. It depends on the algorithm. Yeah, but yes, sorting does have a better effect in what we are seeing. That's why there is a lot of sorting algorithms there, and we will go and study them one by one, how to sort an array, a big array, fast enough. Okay, so
Okay.
yeah, so now binary search is about doing a way that we can reduce the amount of comparisons that we have. So imagine now that you have this kind of no, let me add one more item to make it easier as a start. So
Okay.
if I add 100 here, so how many elements here?
5
Good. And what is the middle?
is
5.
5. Oh, I think I can guess what binary search is. It will search on the middle first, and if it's low or high, it will know it's low or high, and it will search another middle of half of the list, right?
Yes, exactly. Yes, you are
Yes.
smart enough to understand that. Okay, yes, you are correct, 100% correct. So, okay, so just a fast illustration. This is an index, and this is the values, and we are searching 25 here. So
Yes.
we will find the middle, like you said, and
Yes.
then once we compare 15 to 25, we know that 25 is bigger. So it means that we
Yes.
will start searching this portion of the array.
Okay.
But again, so you understand this, the concept is great. We just need to know how to implement that in code, right? And study the number of comparison that we.
Yes.
So again, once you come up with another midpoint, so you will keep. So imagine that you have 1 million number. You will keep doing midpoints, searching for midpoints, and then comparing the value here to the value you are searching, and then so you, if there is the array is bigger, then you will move to another portion, and so on.
Yes.
Okay.
I think the code will be so much interesting.
Yes,
I think I have some idea for that, but
okay,
wow.
have a look. So as the code is actually simple, because this is an algorithm that to reach it, then the of course take a lot of time to be able to make it a standard like this. So this is fixed. This is a fixed algorithm that it
Yes.
doesn't depend on the
Depends on
implementation of
case,
people.
right?
I mean,
Yes.
yes, you learn it like this. So okay, we have to create a flag. We have to make a while loop. Okay, this is a flag,
Okay.
and this is a found index -1. The first and last mark the here first. Here is marking the last, the end of the array, and
Okay.
we say we will only end the loop if we will keep running the loop as long as first is less than or equal last. Okay, so you see first
Okay.
here and last. So it means that we need one of them to come to each other to be able to end that. So we need to keep shifting first or shifting last so that they can come together. Then we know that this is the end. We no need to continue anymore. Okay, if you don't understand it, wait a while. So first,
Yes, I
how
can
we
understand.
find midpoint. Midpoint, of course, get the first and last and divide them this way, not this way. So you need to get, so if they are seven elements, you divide them by 2, give you 3.5. But there is no position 3.5, so you just do the integer division where you get only the integer portion of the division. You understand that?
Okay. Yes, I understand.
Okay. And then you do an if statement. First, you start with searching them if the midpoint here actually contain what you are looking for, which is 25, and here was 15. So
Yes.
if it doesn't, you go to the else if. So the else if say, does this 15 less than 25? Yes, it is less than 25. So what you do to the first, now you move it here. So you add the position of the first, and instead of first 0, you make it midpoint plus 1. This midpoint that you calculated here, you
Okay.
add 1, and then you assign that to first. So first become here. And then last remains the same, because we know that we're going to search the whole portion here. And then after this, okay, we loop again. And we check first less than or equal last. Yes, it is still like that. And found still false. Okay. And then we find another midpoint. Then we calculate another midpoint here. Okay. So here there is 25, and we are searching 25. So it means that this if statement will work. It will be executed here. And then we will find that the midpoint, the position of this here, will be assigned to a found index, and we will say found flag equal true. So it means that once we come out here, we try to run the while again, we will find that found is equal true, so we will end up, the loop will not continue. So do you understand what I tried to tell you here?
Okay, that I confused a bit, but now I can see that else part will move the last part of midpoint -1.
Yes, if
That's
it is,
the most amazing part of
yes,
this code. Wow.
yes.
That's very
So it is
interesting.
simple, but it is, again, listen, it's
Yes.
simple, right?
Yes, this is, oh wow. This code is so good.
Yes, it is good. That's why it is taught in the programming books for all the
Wow.
students. Okay, so
I
now,
think, oh yes.
yes,
Okay.
please tell me. No, you tell me.
Oh, the first person who wrote this code deserve a Nobel Prize.
Okay, but
Yes.
wait until you study other codes. So
Okay.
now, okay,
We need so many Nobel Prize, right?
yes, smart
Yes.
people deserve it. Yes. So again, this is something is interesting to you, right? But
Yes.
then remind me, there is something I need to share with you about linear code, please. Linear search. There is 2 different algorithms for linear search, and there is a big difference between both of them. One using the for I shared to you just now, and there is another that using the while, and that actually reduce the amount of comparisons by a lot. But let me just share it with you after I finish this. So, okay, again, now we would like to see if we have items in a list, and the items is 10. So the number of comparisons that you're going to perform is 4. Okay.
Yes.
And
Yes.
if it is 1 million, it is only 20 comparisons.
Yes,
just to
it will
reach.
more efficient with a
Yes,
bigger number. Yes,
yes,
but
exactly.
if it's small, it's more efficient in the linear search. I can
Yes,
get it.
no, but yeah, I mean, if you are talking about, but wait, no, who said? No,
Okay,
no, no,
okay.
no, wait. Okay, again, if you have 10 items
Yes,
in the binary search, if you have 10 items, you're going to search maximum comparison of 4 times. If you
yes,
have if you have a linear search, you have 10 comparisons.
yes. But you're about to say there is a better search
Yep.
algorithm than
Yes, but
binary.
no. I mean, no. But there is other than binary. Yes, definitely. But what
Yes.
I'm trying to tell you is that at the current comparison between the linear and the binary wins even on smaller items in the array. Binary
Okay.
wins. It totally wins.
Yes.
Okay.
Okay.
Okay. Good. So how we know the number of comparisons? Just a simple way, very simple way. So you keep dividing. So if the items in the array is 2 divided by 2, sorry, item in the array is 10 divided by 2, 5, keep dividing it by 2.
Yes.
Here 2 and get rid of the decimal points. And then 2 by 2 equal 1. So you keep dividing until you reach 1, and then you count that. Okay, and then that's the number of that is the number of items. So,
Um,
so
five
number of
divided by two
comparisons.
should be 3.
Sorry, again.
I think 5 divided by 2 should be 3. So 3 divided by 2 should be 2 and 1. So binary search binary search comparison of 10 will be 4, right?
It is up to 4. Up to 4
Yes.
is up to
Oh,
4. Yes, but
yes.
the way to estimate the number of comparisons, you can do this way.
Ah,
Okay,
okay.
so that is how they put it here this way. Okay, so
Okay.
then the maximum is 4. Yes, and now we look at this big notation. Okay, so look here and how it looks like. So this is the O log n. So so when we are doing the binary search, we are actually, it is true what you said
Oh,
just now. You increase the number of items, the actually the time complexity does not grow so much higher.
yes.
It's not
Now I can
the
understand.
same
Yes.
now, not the same like the linear search. So that
Okay.
is actually the I can say the difference. Okay.
Yes.
So
Okay.
now let me go back. Let me see here. Yeah. So and this is in Java, this is in Python. So just now we talked about the for loop, right? We talked about for loop,
Yes.
and we talked about can you remember the for loop, right?
Sure.
Okay, good. So have a look here and tell me, when you look here, what is the difference between that code and the code that you see for the for loop of linear search?
Okay. Mm, um, does it work until it found? Like
Uh,
when the item is found, it will end immediately.
yes, and the
Is
for
there
loop
a
will not end immediately. So
yes?
the
Is
for
there a
loop,
difference?
yes, a
Ah,
big
okay.
difference. So when you keep searching, so okay, let's go back. I think here, yeah, Python. So look
Yes.
here, please. You see here. Um, so here
Oh,
you keep looping until you reach the end of the array, even if you find your item.
yes. I did use for loop on last exercise, right?
Yes, yes.
Yes,
So
that was very stupid. I
not
did the
not stupid, but I mean, just for you to know that sometimes list comprehension is not the best thing, because you cannot implement the binary search, for example, in list comprehension. It's very hard
um
to achieve that. So
um
that's why efficiency and clarity sometimes could be slightly better.
can I use while in list comprehension?
Uh, I never tried it, to be frank. I have to try it and confirm to you it can be used, but I never tried it. I never see it in any book so far.
Okay.
It's only
So it's
a
not a
for loop
good
that I've
way,
seen.
right?
So when you write while also, it is not readable at all if you put it in a list comprehension like that.
Okay.
Most of the list comprehension and even dictionary comprehension is used with for. I would say 99% of the list comprehension and dictionary comprehension I've seen is using for, and
Okay.
none of them ever use while. Okay,
Okay.
and they combine. I think you have done that before. I've seen your code for that. They combine for with if also. Okay, because
Yes.
for does not have any if statement. So that's why I believe that almost none of the list comprehension is using while. Okay,
Mm, okay.
so now I think you understand somehow how that works. But now let me
Yes.
share with you as another examples of all. Yeah, okay. So we need to look at what does it mean by on, by o1, sorry, not on. So we have seen on, we have seen o log n, and then this is o1. So what is an example of an o1? Have a look here. This is one line of code that does not get affected by the size of its input. So that's why we always say it is O1. Where did you go?
Uh, uh, it it didn't it didn't mean to find the certain
No,
element,
it's no
right?
searching. No searching. It
Yes.
is just
It
returning the first element. And this
yes.
is just an example code of how they use O1. How to measure, how the time complexity of a function can be decided as O1. Of course, this is a new field. I mean, this is a new thing that we are trying to enter. The ON, big O is not a simple topic. So just bear with me. We will take a little bit by little bit. Okay. But this is
Okay.
an example that your function does not depend on the size of the input. The size here
Okay.
can be a million, 1 million,
Yes.
or
But
something like
it
that.
doesn't matter.
But it doesn't matter because we only
Yes.
take a fixed, we take only the first element at index 0.
Okay.
That's it. Okay.
Yes.
So, okay. Now let us have a look here. Another example of ON. So if you here trying to find the maximum.
I have some question.
Yes, please.
Um, Also, I think max function will also using searching algorithm, right? Does it use
Definitely.
searching algorithm?
Yes, definitely. And it's more optimized than our own functions that we can ever write. Yes, definitely.
Yes, if I use element list with like 1 million element, max function will take some time, right?
Definitely, it will take some time, but I'm sure that it will find it fast. But you have to understand that the max function, I don't think they use I don't think they use so much um, um, algorithms like the binary one, because they they are not, how to say. Okay, so let me explain this in a simple language. Okay,
Okay.
when you pass maximum, does it tell you give me an ordered list, or it accept any list from you? It will accept any list. It doesn't tell you give me an ordered list. Okay, so
Okay.
so even if it want to use a binary search, it have to do the arrangement or the sorting of the list first. So definitely, when you give a million item array and you ask it to sort it first, so definitely that also is a time that we not. So you are not talking only about comparisons now, of just 4 comparison when you, or 20 comparison when you have a sorted list, like we talked about just now. So definitely the maximum will not be O log n, because it have to sort the array first, and the bigger the array, the sorting will take time.
Okay, so the only algorithm that I can use in comparison will be log n and just n, right?
Yes, possible.
There is not better way, right?
Can you repeat the question again, please, so I can.
Okay. I'm so sorry.
I mean,
So
I just didn't catch it, so you no need to rephrase, just repeat it again, so I try to digest it.
yes. So the searching algorithm,
Mm-hmm.
there is there will be only two way to
Linear and binary?
way.
No, 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 no. There is other things, but there is other things definitely. And there's not only these two. No. So
Okay.
and even sorting an array itself, there is many algorithms that we will study. It's not
Yes,
only
for
one.
sorting algorithm. Yes, I used to enjoy watching sorting algorithm on YouTube. There,
Oh,
I saw that there is hundreds of sorting algorithms, but I wonder, um, comparison is not like sorting algorithm, right? There is, I think,
sorting algorithm definitely have also big O, and they are able to compare it somehow with a big O, so that they can decide which algorithm is fast and which is not, and so on. Yes, but wait until we talk about it, and then we talk about big O for that. Okay.
okay,
Okay. Now I want to tell you here that um, so if you're trying to find a maximum in a list in this beginner way without using the maximum function, so you can start to see here that
okay,
the bigger the array, the bigger the search that we will keep doing. Because why? This is not a sorted. If you look here, he tried to find the maximum, right? So
yes,
and here it is uh, definitely not the highest. The highest is in the middle. But then he have to compare. Once he gets so he start here, he put the maximum equal 5, and then he will loop through the array from starting here until he reaches the end. He cannot neglect, or he cannot say I only can take a midpoint and then compare, or no. He have to really search, because he's searching for the maximum, right? So it means that
okay,
if you have um, 10 items, he have to do a comparison, 10 comparisons.
Yes.
And if you have 1 million, he have to do 1 million comparisons. So that is
Yes.
how we say this is ON. So it
Yes.
grows, the time complexity grows linearly.
Linearly. Yes.
Yes. So that is how, that is a second example of a search.
ON. Yes.
ON.
Oh,
Yes.
okay.
Okay. So that is what I wanted to actually share with you. And let me see. I want you to also let me see here. Yes, that's yours. Why I cannot search? Yes.
It's not important question, but do you have you ever thought about hacking or the security what is that about security or hacking?
Yes.
Have you
Yes.
ever thought